everyone. My name is Ioana, and this is my colleague Carina. And today we're going to present the nuts and bolts of vulnerability detection in multi-cloud environments. To be more specific, AWS and GCP. So a little bit about ourselves. We're both software engineers at Pentest Tools. Carina did her master thesis on vulnerabilities in Google Cloud Storage, and I did my bachelor thesis on AWS, IAM, and S3 services. The result of our research was a new tool in the Pentest Tools platform called Cloud Vulnerability Scanner. So today we're going to walk you through the reasons why we started our research, what we discovered, and we're going to finish with a short demo showcasing the capabilities of our tool. It's the first time we're doing this, so if any mistakes slip through, we apologize beforehand. So why should you care about cloud security? Well, as we can see from these two charts, the revenue of cloud providers has been on the rise in recent years, and through 2025, it is predicted that it will surpass their traditional counterparts. From this, we can take the conclusion that more and more organizations will move their services on the cloud to benefit from increased scalability and computational power. So the top cloud providers are in order Amazon Web Services with a market share of 34%, followed by Microsoft Azure with 23%, and finishing off with Google Cloud Platform with 11%. So security is a top priority for organizations of different sizes and types. And this is because cloud infrastructures function by a shared responsibility model, where the cloud provider is responsible for the security of the infrastructure, whereas the access to the stored data and services is configured and is the responsibility of the end user. Because of this, through 2025, it is predicted that 99% of cloud security failures will be because of the customer. So to further prove my point, some security incidents in recent years. 1 month ago, we had a S3 bucket misconfig of a pre-signed URL, which allowed an attacker to gain access and download files in a bucket. This resulted in a $20,000 bug bounty prize. In 2022, we had 3 terabytes of sensitive airport data and the grades and personal info of 100,000 students exposed. And in 2021, we had a famous Turkish beauty brand who got its data leaked. So now that we've handled the whys, let's move on to the hows and see how we actually hack AWS S3. So for a short introduction, a bucket, as its name implies, is a sort of a container in which you can store files that are called object or keys. The bucket can be accessed using an URL matching that form, bucketname.s3.amazonaws.com. And it's important to keep in mind that the bucket name is unique in the whole AWS infrastructure. And it's pretty easy to determine if a bucket exists or not. I mean, we only have to make a GET request and look at the response. And that means that if someone would want to enumerate a set of buckets and check if they are vulnerable, it's very easy to do. But here we have a problem with determining ownership, because there is no rule preventing me from creating a bucket, matching any name, as long as that bucket doesn't already exist. So when we call a bucket public, we mean that 2 types of groups have access to it: the authenticated users, which match any IAM user in the AWS infrastructure, not necessarily in the buckets organization, and the unauthenticated user group, identified by the all users, which also include the authenticated users, and let's say an asterisk using the bucket policy, which, as you know, matches everything. So some relevant bucket permissions that our tool detects and we deem relevant, they are grouped by read access and write access. On the read side, we have permission to list the bucket content and permission to see the content of a file. We also have permission to see the bucket ACL, which is a set of rules that determine the access to the bucket. It's not necessarily a good practice to use ACLs because they are not granular, meaning that you can configure the access to the whole bucket, but not to a specific file in a bucket. On the right category, we have permission to upload or override a file in the bucket and permission to modify the bucket ACL. And that will allow an attacker to gain access to the bucket content. Some relevant configurations that are nice to have, and it's a good practice to have them configured. But the problem is that if somehow an attacker were to be able to modify some of these configurations, it will make the bucket vulnerable. Let's take, for example, replication. This is a set of rules that determines in which bucket the files in the target bucket are copied. So we can have a copy of them in case something bad happens. So, if an attacker were to add a rule or modify an existing one and change the destination bucket and put one that he owns in place, he would ultimately gain access to all the files in the bucket. So how do we discover misconfigurations? Well, we use the Python boat2free package to query AWS with an unauthenticated and authenticated client. For post requests, so we don't modify the target, we send them deliberately with an invalid body. And this works because AWS handles requests by first looking at if the permission is present, and only then looking at the request and see if it is valid. So responses differ depending on the access level. If the action is permitted and the response was successful, we get a 200 OK. If the action is not permitted, we get a forbidden. If the bucket or object do not exist, we get a not found. And if the request body is invalid, we get a bad request. But this means that the action is actually permitted. So to sum up, if an attacker were to gain read access to a bucket, he could cause a data breach. He could access documents containing sensitive information, such as credential or tokens or API access keys, depending on what is stored in the bucket. And it could help him identifying further misconfigured objects by reading the ACL. If he were to gain write access, he could overwrite data, gain additional access to the bucket and infrastructure by modifying the ACL order configurations, or he could serve malware to end users if the S3 bucket somehow hosts a static website, or if, let's say, the data in the bucket somehow ends up to the end user. Thank you for your attention. I'm going to let Carina take it from here.
Okay, so regarding Google Cloud Platform, there are a lot of similarities to Amazon Web Services. Regarding the storage service, Google Cloud Storage, there are many equivalent features. The main entity in the Google Cloud Storage is also called a bucket, and it contains multiple blobs, which we can also refer to as objects or files. This is the format URL as dictated in the Google API documentation. And if we want to find out if a bucket with a specific name exists, we can simply make a request to this URL, and we can have these responses as returned as options. If we get back not found or a bad request, it means that the bucket doesn't exist. If we get a forbidden response in return, it means that the bucket exists, but is private. We cannot access it without the right credentials. And if we get a 200 OK, it means that the bucket is public, and anyone can see some information regarding it. What type of information? Let's find out. Okay, so first thing we can do is retrieve the list of the bucket permissions, and they can be of two types, depending on how we access the bucket. If we access it as an unauthenticated user, which means basically any user on the internet, using the Google public API, we'll get the list of unauthenticated permissions. And if we want to retrieve the list of authenticated permissions, which might differ, we simply need to access it using an authenticated account. And we can do this, for example, using the gcloud utilitary, or the Python Google Cloud client by inputting our service account credentials into it. Okay, again, a parallel with the S3 service. Some relevant bucket permissions for an attacker might be, for the read category, we have permissions regarding the bucket itself. We can retrieve details about it, the metadata, for instance. We have permissions regarding the objects contained, such as listing the bucket contents or reading the contents of a single blob. And we also have here the permission to see the IAM policy of the bucket. And in the right category, we also have permissions regarding the objects, such as creating them, new ones, deleting existing ones, or updating. And last but not least, we have the very interesting permission of setting the IAM policy, which is modifying the bucket ACL, which can lead to, yeah, you see it right, privilege escalation. How this can be achieved, I will detail in the next slide. Okay, so we found out that we have this permission to update the bucket IAM policy. We can simply make a request to update it with the desired role. For instance, roles /storage.admin, grant it to the all users entity, which represents all users unauthenticated publicly from the internet. And then the operations we perform on the bucket will be from the role of the admin. Okay, the access control on a bucket can be of two types. The default one is the uniform bucket level access. And this says that the permission across both the bucket and its objects is the same. There is the same set of permissions. And another type of access is the fine-grained one, which the user has to manually enable it. But this allows us to specify different types of access levels to different objects in the bucket. But we recommend sticking to the first one because this one guarantees that if a bucket is private, all the objects contained in it are also private. And some relevant configurations of the bucket, which might be useful for an attacker. Logging, to start with. If you don't have logging enabled, in case of a security event, the audit trails are not existent, so you can't trace the incident. We also should have object versioning or a retention policy enabled, because also in case of a security event, the objects, the contents of the bucket can be attempted to be overwritten, and this would prevent an attacker to do so. A customer-managed encryption key can also be useful because it can provide an extra layer of encryption. Also, setting a course policy might be useful in the use case where you want to control who can access a specific endpoint in your application. And some other configurations that might be useful for you. Labels can help organizing the cloud assets better, which can prevent some misconfigurations. And setting object lifecycle rules can prevent extra costs. Okay, we also have here a list of open source tools. If you want to play or check out the detecting vulnerabilities in cloud applications, these are all available on GitHub. Some are more focused on specific services, such as the S3 of AWS. Others are more generic for multi-cloud environments. To conclude, some mitigations and good practices in order to keep your cloud assets safe. Always use the principle of least privilege. Always try to add as many layers of security as possible. For instance, encryption, enable multi-factor authorization for sensitive operation, and don't forget to monitor your assets continuously. Okay, let's move now to a more exciting part, the demo. What I'm going to do in the demo, as my colleague Ioana mentioned at the beginning, on pentestools.com, we integrated this research we did into a new tool, Cloud Vulnerability Scanner. And I think we can see it, right? Okay. This is the tool page. Currently, it has these two tests. The first one is detecting the cloud provider of the input target. And we can start just from a simple address, such as a host name or an IP address. This step of detecting the cloud provider is done using the publicly available IP ranges of the cloud providers. And then it tests automatically for cloud vulnerabilities and misconfigurations. I already have some demo targets prepared here, an S3 bucket, and the Google Cloud Storage bucket in the URL format. And I will perform a scan with Cloud Scanner. The scan options are here. Okay, and by the way, I am accessing this with a free account, which you can also do on pentestools.com, ideally after the presentation. Okay, let's also refresh. I think the scans are finished. Oh, it's filtered on the target, okay. So the AWS scan is still running. Let's check out the GCP one. Let's see what it discovered here. So first of all, it discovered that it is a publicly writable Google Cloud Storage bucket. And we can access it on the URL. We see here the JSON response. Here we also have the list of permissions. These are when accessing the bucket with an unauthenticated account. And this one is when accessing the bucket with an authenticated account into a Google account. And we can see that it returned more on this side. Then some metadata about the bucket. It also retrieved some files contained in the bucket. Okay, and the rest of the findings are regarding the configurations. We see that the type of access is not uniform, as it is recommended. Also detected that logging is not enabled, nor an object versioning or a retention policy, and also retrieved the ACL of the bucket. Okay, let's go back to the AWS scan of the S3 bucket. It also found the publicly writable bucket, the permissions, the number of files contained in the bucket, which are here, and similarly ACL and some configurations. Okay, and the last thing I want to mention, in the evidence of some findings, you can also find some comments if you want to reproduce this finding yourself. Okay, I think this concludes my demo. If you have any questions.
Hello, thank you for your presentation. Just to know, Pentestool is available for Azure cloud provider or only for AWS and GCP?
Yes, for Azure, currently we only have support in the first test to detect if the cloud provider is Azure. And we are also working on adding tests for detecting vulnerabilities.
It's Pentestool PCI approved scanning vendor?
You are asking if you are approved to scan the vendors, right?
Yes.
Okay, well, We use the public API in both cases, so it's not necessarily a problem. It will be a problem if for the customer of that cloud provider, not for the cloud provider itself.
Okay.
Hi, thank you for your presentation. I was wondering if, as a customer of the cloud, would I be able to see that I was scanned, so to say, with your tool?
We didn't really focus on the configurations in the cloud provider, but I think, yes, there should be some logging, some traces.
If you have logging enabled for the bucket, you should see that someone tried to access it.
Yes, but would I be able to identify that it was Pentest tools?
We use authenticated client configured by us, so maybe you could, but it's problematic a little bit.
Okay, thank you.
Hi, are you planning to offering scanning also for Oracle Cloud?
For what?
Oracle Cloud? Or only
Not
for-
yet,
Ah,
but
okay.
stay tuned.
Okay, thank you.
Hello. I'm quite interested if you're trying to mix your scanning of the cloud provider with the scanning of the vulnerabilities on the host. And by that I mean, it's well known that you can lose AWS or GCP keys by abusing a poorly configured server through request forgery and grab the keys. The session will remain active, and then the adversary will be able to move laterally in your AWS account, Azure account. Did you, by any chance, map this in-depth exposure to double vulnerabilities, misconfigurations like using IMDS version 1 with vulnerabilities on the host?
AWS question.
Or Azure, it works the same. They have the same vulnerability.
Well, it's something that we thought about, but it's not yet implemented in the tool. We try to focus more on the S3 service and buckets for now, but stay tuned.
Yeah, we started with storage, and we plan to add tests for more services like IAM, and maybe change the vulnerabilities, as you said. And we also, in the platform, have also web vulnerability scanners and the network vulnerability scanners, if that helps your use case.